Right, so as you can see, I've got the 5200 on the bench again. Now this, I want to go through calibration and just try and see if I can identify any issues still present. I know the output voltages aren't rock solid like they should be and that kind of thing. So I want to just go through the calibration, see if that improves anything or if it identifies any problems. That's the plan. So I've got the printout of the paperwork here, which I've been using a fair bit. And I've done this for the troubleshooting stuff, individual boards, and I'm not going to go through that part. What I want to do is just look at the calibrations though. So once I find it again, it's in here. I've lost it now, haven't I? There you go, calibration procedures here. So I've got the meter already turned on here. No leads connected yet, I'm not quite sure which leads I need yet. And I'm just going to go through and just follow the procedure and see what comes out of it. Now the very first thing here is power supply calibration. Now I know this is all fine. I've done this several times. It's blown up a few times and I've had to repair it over and over again. So I know the power supply is okay. So it probably doesn't really need doing. I mean, I know it's okay. I'm comfortable that's all right. I've checked it so many times, and each time it's been okay. Once I've repaired it. So next thing is power amplifier bias calibration. So I'm going to do this one here. Now let's need to read it. I should put this off camera actually, but anyway. So remove covers between TP5 and TP4. Power amplifier should read between 0.34 and 0.36 volts DC. Right, I better get some probes then. Hold on. Probes. Here we go. Okay, so I've decided for the sake of completeness I might as well do these voltage measurements, right? So I've got it prepared. So I want to do, according to the book here, we want TP8 and TP5 on the power regulator, which is this card here. TP4 and TP5. Sorry, TP5 and TP8, wasn't it? Sorry, TP5, TP8. Here's the drawing. One more page. Right, TP5, TP8. Okay, so it's that point there. It's TP8, that's TP5 there. Okay, let's have a look. So TP5 there. And TP8 here. 14.99. Could be better. Let's just give this a twiddle. There's actually quite a loose pot on here. I'm not actually sure it's actually any good. I might need to replace it. Might be a bit dirty and stuff, so let's just try it again. It should be 15 volts, pretty much exactly. 1, 2. It's going to be plus or minus 10 millivolts. It's close. Yeah, it's just about there. I'll leave it there for now. Okay. It should be bang on 15, but I'll tweak it some more later on. I think I'll change that pot. It's ridiculous. So the next stage is expect 190 volts. TP3 on the A7. So there's actually a ground point over here. I can measure from there rather than trying to do there and here at the same time. So I can do that. There should be at least 185 volts DC. If it's less than that, then I have to adjust R32 to compensate, apparently, which means doing a calibration there is maybe pointless. Anyway, right, we'll see. So TP3, now this is the ground point here. Again, you'll be really careful what you're touching around here. There's all sorts of stuff. So that's the ground there, which is fine in that post. Now TP3 is down there. It's like the bottom of V. 188.5. Good enough. Good enough. So that's that part fine. So now I can go back onto this amplifier calibration thing, which so I had to wait 5 minutes so I could do that. Okay, so sense to internal sense. Yeah. So in TP5 and TP4 on the power amplifier, I should read between 0.34 and 0.36 volts. So I should be basically 0.35 plus or minus 0.01 between TP4 and TP5. Might see if I can get some probes with bloody clips on. Actually, this is a bit tricky. Right, TP4, TP5, where are they? There's TP4 and there's TP5 right there. So I should be getting 0.6. It's a little bit different, isn't it? Now I think I need some probe clips. This is I'm sure I've got that I can get in there with though. Alright, where's the adjustment for that anyway? Let's see. Just R26. So I have to do R26. Which is, I believe, this one right here. So let's get my adjuster here. Insulated, metal blade tip on the end. Let's get those in there. Hopefully without slipping them off. Be a little bit tricky one-handed. Must not short anything out, that'd be really, really bad. Okay, it's on there. .35 is what I should be going for. There we go, done. I need some. The only clips I think I've got are these crocodile clips ones. I might have some other type I can like little hook clips. I've got some somewhere. I have to look. I might have to dig them out for this. So that's that one done. So I doubt it's changing anything, but I mean that was wrong. So I might actually just have a look at the AC output and see if there's any change on the outputs. I doubt it, but you know, you never know. So what I'm set to right now is 100 millivolts at 100 hertz. It's jumping around a lot. Let's go to 10 kilohertz, shall we? Still jumping around a bit, eh? So if I look at the display options, do a trend chart again, see if it's jumping around a lot. And yeah, it looks like there's a little bit there. It could have just been me moving the probes around. But there is no loading on the output, so maybe I need to put load on the output. It could just be that. What we're changing by there, quite a bit actually. We're changing by 60 millivolts, which to me seems a bit excessive. Okay, so I've set up for the next measurement, and I've got it running, as you can see. Now I've got it at the manual says to do 1.19 volts at 10 hertz. Okay, which is correct. This is off. Internal sensing, phase lock off, that's all fine. Okay, so I hooked up onto TP1, which is the ground point, and TP5, which is test point over here. Now it says to use a 10 kilo ohm resistor in series with the lead from DVM. I'm not sure why, but it does. Maybe it's to do with loading or something. And it says to adjust R110 for a reading of 0 volts plus or minus 10 millivolts. Well, I'm getting minus 140 right now, so that's way off. So we'll give that a tweak. My hand might be in the way of this thing. Let's see if I can get that over here a little bit. There we go. So 0 plus or minus 10. I like to go for as accurate as possible. Anyway, it's well within spec there, but might be a little bit dirty actually based on why it's jumping around a little bit. Let's give it a clean like that. I don't know. 1 millivolt. It's jumping around a bit there, eh? Let's do the trending again. What does this say it's doing? It's jumping around a little bit. That may be related to the issue I'm seeing with it as well. But it's within spec. It's not going out of that plus or minus 10 millivolts. So it's within the range it says for the 0 point, but it's noisy. So that's an interesting little note. I might just make a note of that. A bit of paper. Okay, so it's been going for a little while now. It's plus 9, minus 6 is the range it's sitting in, but that noise is interesting. Okay, so that was the Integrator 0 calibration. I should specify that too. That's what we just did, the Integrator 0. The next thing we've got to do is a high frequency compensation calibration. So I need to set it on 10 volts. So 10 volts. The 10 volt scale, go on there, and 1.1999 megahertz and 1 megahertz range, the highest frequency you can do. Right. Right, highest frequency you can do, and internal sensing TP1 on the oscillator PCB, which is this one here, and TP6 of the oscillator control PCB. Interesting. I might take that as being TP6, but we'll try that. That's TP6 right there. And oh, of course I'm using a probe still without that. I shouldn't be having it on there. Hold on, let's change things around. Don't need that now. Let's get a clip. Hopefully I can get that in there. I think that's it. Let's go back to number display. This is TP1 on the oscillator PCB and TP6 on the oscillator control PCB. So where's TP1 at all? There. So, okay, stick it over there then. Not sure why it needs to be there, but anyway, that's what the manual says. And connect. Oh, 10 ohm resistor in series with a high leader DVM, which is what I had before. Okay. Okay, I'll put it back. I should read a bit further ahead. This up onto here. So this is TP6 right there. Right. And then what? Adjust C54 on the oscillator control PCB for reading of plus or minus, or 0 plus or minus 200 millivolts. Okay. Well, I'm kind of there, but it's jumping around a little bit. Let's go back to trend chart again. Again, very noisy, so TP6 is noisy as well. So this noise is potentially a clue to what's going on. So C54 is which one? Where's C54? There, I think. I believe that's it. Let's just look at the diagram here. Let's confirm it. C54, just next to R10. Yeah, that's it there. Okay. Well, let's just see if we can improve this slightly. Got this trim here, it should get down there quite nicely. It fits on there. Might be too recessed. Oh, that's on. Right. Now there's still a readout up here. I'm not really seeing it changing. What do you think? Do I have something wrong here? This isn't doing what I'd expect it to do. Let me reread this. Well, I'm in the right places. 10k resistor. I'm not sure what the 10k resistor is supposed to do really. I mean, I've got a high isolation multimeter here. Might have to do with their own equipment. Might be to do with the actual calibration equipment you're supposed to be using. So this may not be necessary. Let's just take this off completely. See if that changes them. That's taking a lot of noise away. It may not be the noise from that. Let's hook on directly with this, because I mean this is a high resistance input on this thing, so it should be fine. Let's do that. Clear the readings. Get a new trend. We'll try doing it without the resistor. Don't forget this is very old calibration procedures. And so things may not be. Yeah, this is now I can see what I'm doing. Right. Yeah, this is all clean now. It might just be this thing here with crappy switches in it. You know. Anyway, so let's try and get this to around 0, and not worry about the 10k resistor thing, which is a bit odd. Anyway. Pretty damn close there. Well, that jumped us into this probe away. Or this adjustment tool. It's not very well isolated then, is it? For a plastic adjustment tool, just affecting it. Anyway, it's basically plus or minus 200 millivolts, but I'm going to try and get bang on the middle and try and get 0. Maybe I should use a ceramic tool for this instead. But it's quite stiff, so I don't want to risk breaking ceramic. It's plus now, so I'm going to go slightly back. Can we get on there? You can never have it. No, it's gone too far now. You can never have enough adjustment tools, all different types. Different styles. You need to have all these different things, you know, because you never quite know what you're going to need and when you're going to need it. Nice thing. Yes, just jumping around a little bit there. Get back on. Might just give up the insulated window. Just do it like this because I can see what I'm doing. Yeah, it's well within anyway. It's point was it 7 millivolts. And it's supposed to be plus or minus 200. I mean, that's well within, right? But I just like to try and get things as close to correct as possible. So let's slightly further. Yeah, that's like 0.5. Right, that's like, yeah, we're happy with that. Okay, so I might really look at that TP5 one again, because that was a bit odd with that bloody noise in there. So maybe that there isn't actually an issue with that particular part. So let's take this probe off here, hook this back up to over there on TP1, which is this one here. Put this back on to that voltage on 10 hertz, wasn't it? 10 hertz, 1.19 volts. Cool. Right, let's do this test again. Let's see if I can get this calibrated a bit better this time. Yeah, that's much cleaner. It's still not great. But it's much better. Yeah, it's still got an issue there. I think TP6 is okay, I can cross that one off. TP5 is noisy. Right. So, that's that part. Still plenty more to go. Okay, so the next stage here, apparently it's two adjustments combined into one because they interrelate to each other. One affects the other. So I've hooked up my, well, I've set up my Recordana 1992 frequency counter. That's on the frequency counter output on the back. This is still warming up, it's only been on for a few minutes, so the oven's still settling down. So it's not dead accurate right now, it's still jumping around a little bit. It's just settling down. And I've got my multimeter set up to the quadrigit output. Now, interestingly, it's supposed to be between 9 and 11 volts. I'm getting -8, which is odd. I'm sure this is the correct way around. I'll have to look at that when I go to do the adjustment. But you'd think it would be the correct way. A little bit odd. Anyway, it's supposed to be a differential voltmeter, but in this case it probably doesn't matter. I don't have a differential voltmeter, and this is isolated anyway. I don't see a problem, so I think it's all going to be fine. Okay, so what it says to check for is in operate mode. So I've got the frequency set, well, sorry, voltage set at 1 volt. Is that correct? Let me double check. 10 volts and a 10 volt range. There we go. 10 volts on 10 volt range, just get that right. Okay. So 10 volts on 10 volt range in 1.0520 megahertz and 1 megahertz range. So megahertz, all good. That's correct. Right. So now we look at. So I've got those connected up as I said. Make sure it's running. That's running. So frequency adjustment first. So frequency should be between 1.0420 1.0620 megahertz. So that's obviously to do with its frequency tolerance now. So, but that's obviously off. And its quadrigit level should be between 9 and 11 volts, and it's -8. So that's also very interesting. So frequency adjustments required. Adjust 1 megahertz A2, which is C41. So 1 megahertz A2 is here, and 1 megahertz A3 C45 equal amounts in the same direction until the frequencies of intolerance. Okay, so A2 and A3 have to be adjusted together. That's interesting. Okay. I'm not sure they're actually adjusted by the same amount. They are very different. I should wind this out a little bit, because these are not adjusted the same amount. I'll bring this up a bit. Because say these have all been twiddled with, so you would think them to be similar adjustment levels. Alright, so let's just do that. Now, so let's adjust this one first, and then we'll do the other one. Obviously it's made it worse, but that's fine. Same amount in the same direction, so let's go that much. And then the same again, that one. Okay, so it should be 5.2. Alright, so let's go for 5.2. close. Now are they in by about the same amount? That's the next question. No, they're different. This one's out. This one's in further. So I might pull this one out some more. I want it to be adjusted by about the same amount. So they're even, like it seems to want. So let's do that again. I mean, the frequency accuracy in this thing's not wonderful, so you're going to expect some variation and things like that. So, yeah, 5203 is like well within spec there, right? And this voltage level is now different as well. So voltage, if voltage level adjustment is required, adjust 1 MHz A2. Interesting. So if voltage levels adjustment is required, adjust 1 MHz A2 and 1 MHz A3 equal amounts in opposite directions until the level is within tolerance. Okay, so it's looking for a difference between these two. So does that mean I need to undo what I just did? But it's still saying -7. So I don't know. Still a long way out, isn't it? Let's put that one right back in again. So I think it's because there's quite a recessed blade on there coming off that adjustment. And right in. This one here right out. So it's still not looking right, is it? And it's only 8. Why is it acting like that? That's really weird. That's interesting, that voltage level, because that is not at all like what I should be expecting to see. Yeah, okay, well, let's keep twiddling this. I'll try shoving this one right down and then we'll do the other one in the opposite direction and I'll see if that gets it instead. Try and get on there. Put them right down, I'll bring the other one right up. I'll do the other way around. Set them right down. This is not cooperating very well, is it? Eh? Just bring this one right up. See, if the frequency is right, the quadrature level is wrong. Something's weird about this. No, I can't get a voltage anywhere near that, you know, or I can't get any voltage anywhere near that at all. So something isn't right. No, that isn't. I can't even get 9 volts, even though it's showing negative 9 volts. It should be positive 9 volts. So I might go back to my original option there, which is try and get them set about the same amount to start with. but something is definitely not right here. I'm going to have to look into this, I think. But for now, I'll get the frequency correct. And then I'm going to have to look into this quadrature voltage. That just seems really weird.